In this video, we will explore the new features for developer, unit, and integration testing in Visual Studio. With Visual Studio 2012, we refocused the testing experience on the kinds of testing traditional and agile developers do each and every day while they are writing their production code. To open the new Test Explorer tool window, select the Test menu, choose Windows, and then Test Explorer. There are a number of things that are different with the new Test Explorer in Visual Studio 2012. Since this experience is meant to be used by developers while they are writing their code, we streamlined the experience for them. You no longer have 2, 3, or even 4 different tool windows showing you similar information. Instead, you have one window that focuses on the unit and integration tests in your solution and on their pass or fail results. By selecting a test, you can see additional detailed information about that test in the pane below, including the result, the messages it may have produced, and the stack trace. We also added a red-green bar to give you a quick visualization of the outcome from the last test run. One of the most important things we changed in the developer testing experience is that we enabled third-party unit test frameworks to quickly and easily integrate into the Visual Studio 2012 experience. So if your team uses NUnit, XUnit.net, or some other framework, you can simply install a Visual Studio extension and get the complete Visual Studio experience with that test framework. By accessing the Visual Studio Gallery via the Extension Manager, and by searching for the test framework that we need, we can find, download, and install support for that test framework in Visual Studio. We spent a lot of time focusing on the performance and interactivity of the developer testing experience in Visual Studio 2012. Regardless of which test framework you use, it is fast, and it also scales up to hundreds of thousands of tests. The developer testing experience is also very easy to use. If you want to run or debug a test that is in your editor, simply choose Run, Tests, or Debug Tests from the context menu. Of course, this is also available with a shortcut key. If you want to filter your list of tests, perhaps by namespace, you can quickly enter a filter string and the Test Explorer will limit itself to only those tests. You can also group your tests by different test properties. Here I am grouping by the test duration to help me find the slowest test in my solution. But I can also switch and group by the test outcome. We know from our own experience that developers should run their unit and integration tests as often as possible. With Visual Studio 2012, a single click lets you turn on the Run Tests After Build feature. And now your tests will run as a part of each and every build you do. You can see here I build my solution, and at the end of the build, the test run is initiated, and I quickly get back my results, with no loss of Visual Studio interactivity. And now as you work on the code, every time you build, you can quickly and easily see the overall health of your system and your unit tests. Of course, developers aren't only interested in their unit tests. There are all kinds of other useful metrics that help them create better designs and solutions. With a single click, you can analyze and understand various code metrics about your solution. For example, maintenance complexity, cyclomatic complexity, depth of inheritance, class cohesion, and lines of code. As with previous versions of Visual Studio, you can use the Code Analysis tool to quickly and easily identify common coding and design mistakes in your code. A new feature we added in Visual Studio 2012 is Code Clone Analysis. Using this feature, you can scan your entire solution looking for clones or duplicates. Code Clone Analysis is smart enough to identify clones that have been modified and groups the results by how strongly the clones match each other. Exact matches are perfect copies of each other and are therefore excellent candidates for some refactoring. Strong, medium, and weak clones have less perfect matches, but still might be worth reviewing. You also can use the code clone feature to find code that matches a selection in the editor. This is a great way to find other bits of code that are similar to what you're writing and either learn from it or reduce duplication and use that code instead. Another powerful metric that developers use to evaluate their software, and in particular their tests, is code coverage. Code coverage analysis is a great way to ask your code the question, how well do my tests exercise my code? We significantly streamlined the way you get code coverage information in Visual Studio 2012. To analyze the code coverage of all the tests in your solution, simply click the Run drop-down in the Test Explorer tool window. Choose Analyze Code Coverage for all tests, and it will do all the behind-the-scenes work to make that happen. When the test run is complete, the code coverage window pops to the front, letting you browse and explore the information about how your tests are exercising your system. Sometimes, especially when you're adding tests to an existing body of code, you just want to see what a select set of tests cover. This is also easy to do via the context menu in the Test Explorer tool window. One thing that most developers know is that faster running unit tests are much more likely to be run. We also know that unit tests which run isolated from one another are more likely to exercise what you want to test and not other things. Additionally, tests which isolate the code being tested tend to be more stable and resilient to changes in other parts of the system. To help developers write fast-running, well-isolated unit and integration tests, in Visual Studio 2012, we introduced the Fakes framework. The Fakes framework lets you easily create stubs and shims to isolate your system under test from the things around it. Stubs are simply concrete classes that inherit from the interface or class that your system depends on. Using standard .NET language features, like delegates and lambda expressions, you can easily provide alternate implementation of the methods, allowing your test to make more precise assumptions about the environment around the code you're testing. Shims are a more advanced feature to help you deal with code that would otherwise be impossible to test in isolation. Using runtime method interception, shims let you take over and replace almost any method call in .NET. Of course, running your developer tests in your IDE is only one part of how you use unit and integration tests as a developer. Developers also expect to be able to get rapid, actionable feedback from their continuous integration build machine, so they know not only that the tests pass here on my machine, but also on a clean, independent environment. The basic rule that we used for Visual Studio 2012 is that if it works in the IDE, it works on the team build server. Unit tests, integration tests, third-party frameworks, code coverage, fakes, all work in your team build environment with very little extra setup and configuration. And of course, with the upcoming release of the Team Foundation service, it all works on your cloud-based continuous integration environment as well. Hopefully you enjoyed this look at the new developer-focused features for unit and integration testing in Visual Studio 2012.